Have you ever wondered what makes a car smart? Is it just a fancy screen on the dashboard? Or is there something more to it? Well, today we're diving deep into the world of smart vehicles, breaking down exactly what they are, how they work, and what the future holds. And trust me, it's a lot cooler than just having a big GPS. So, let's start with the basics. A smart vehicle, at its core, is a car that uses advanced technology to assist the driver and enhance the overall driving experience. Think of it as your car having a brain. This brain is made up of a network of sensors, cameras, radar, and powerful computers, all working together in real time. You've probably heard terms like ADAS, which stands for Advanced Driver Assistance Systems. This is a huge part of what makes a car smart. ADAS includes features that are already common in many new cars today. For example, adaptive cruise control. Instead of just setting a speed, your car uses sensors to maintain a safe distance from the vehicle in front of you, automatically slowing down and speeding up as needed. It's a game changer for long road trips and rush hour traffic. Then there's lane keeping assist. Ever feel your car gently nudge you back into your lane when you start to drift? That's not a ghost. That's your car's cameras reading the lane markings on the road and helping you stay centered. It's an amazing safety feature that can prevent accidents caused by a moment of distraction. Another one is automatic emergency braking. This system uses radar and cameras to detect potential collisions with other cars or pedestrians. If you don't react in time, the car can apply the brakes for you, potentially avoiding an accident altogether or at least reducing its severity. These are just a few examples of ADAS features that make our drives safer and less stressful. But smart vehicles are about more than just safety. They're also about connectivity. This is where the Internet of Things, or IoT, comes into play. Your car is no longer an isolated machine. It's connected to the internet, to your phone, and even to your home. This connectivity allows for some incredible features. You can use a smartphone app to remotely start your car, lock or unlock the doors, and even check its fuel level or battery charge on a cold winter morning. Imagine preheating your car from the comfort of your kitchen. That's the power of a connected car inside the vehicle. This connectivity transforms the infotainment system. We've moved way beyond CD players. Modern systems seamlessly integrate with your smartphone through Apple CarPlay or Android Auto. You can access your favorite navigation apps, stream music, listen to podcasts, and even have your text messages read aloud to you, all while keeping your hands on the wheel and your eyes on the road. Voice assistants are also becoming standard. Just like you talk to Siri or Alexa at home, you can now talk to your car. You can say things like, "Hey, car, find the nearest coffee shop," or "Call my mum," and the system will handle it for you. This makes interacting with the car's features much safer and more intuitive. Now, let's talk about the next big step: autonomous driving. This is where things get really futuristic. The Society of Automotive Engineers has defined 6 levels of driving automation, from level 0 to level 5. Level 0 is what we've had for decades. No automation at all. The driver is in complete control. Level 1 and Level 2 are what most of us are familiar with today. These are the ADAS features we talked about, like adaptive cruise control and lane keeping assist. The driver is still fully responsible for driving, but has assistance from the car's systems. With Level 2, the car can control both steering and acceleration, braking simultaneously. But the driver must always be ready to take over. Level 3 is where it gets interesting. This is called conditional automation. In certain conditions, like on a highway in clear weather, the car can handle all aspects of driving. You could, in theory, take your hands off the wheel and your eyes off the road. However, you must be ready to intervene if the car requests it. This level is still a bit of a legal and technological grey area. And we're just starting to see cars with these capabilities hit the market. Level 4 is high automation. A Level 4 vehicle can drive itself completely within a specific defined area, known as its operational design domain. For example, a self-driving taxi that only operates in a certain part of a city. In that area, it doesn't need a human driver to take over, ever. But if you were to drive it outside that zone, you'd have to take control. And finally, Level 5, full automation. This is the sci-fi dream. A Level 5 car can drive itself anywhere, in any condition, without any human intervention. It might not even have a steering wheel or pedals. You're simply a passenger. We are still many, many years away from this level of technology being widespread and approved. So, how does all this autonomous tech actually work? It's an incredible symphony of sensors. First, you have cameras. Lots of them. They are the eyes of the car, providing high-resolution images of the surrounding environment. They're great for reading road signs, detecting lane lines, and identifying pedestrians and other vehicles. Then there's radar. Radar systems send out radio waves that bounce off objects and return to the sensor. By measuring the time it takes for the waves to return, the car can accurately determine the distance and speed of other objects, even in bad weather like rain or fog, where cameras might struggle. And one of the most crucial pieces of the puzzle is LiDAR, which stands for light detection and ranging. LiDAR works similarly to radar, but uses laser beams instead of radio waves. It spins around, sending out millions of laser pulses per second to create an incredibly detailed 3D map of the car's surroundings. This gives the car a precise understanding of its environment, down to the centimeter. All the data from these cameras, radar, and LiDAR sensors is fed into a powerful onboard computer. This is where the magic of artificial intelligence and machine learning happens. The computer's software has been trained on millions of miles of driving data, allowing it to interpret the sensor information, predict the actions of other road users, and make decisions about how to steer, accelerate, and brake. It's an immensely complex process that happens in fractions of a second. The future of smart vehicles is even more exciting. One of the next frontiers is V2X communication, which stands for Vehicle to Everything. This allows cars to communicate with each other, with the infrastructure around them, and with pedestrians. Imagine your car getting a signal from the car ahead of it that it's braking hard even before you can see the brake lights, or your car talking to a traffic light to know exactly when it's going to turn green, allowing for smoother acceleration and better traffic flow. V2X could even allow a pedestrian's smartphone to send a signal to a nearby car, warning it of their presence as they're about to cross the street. This interconnected network has the potential to dramatically reduce accidents and traffic congestion. Of course, with all this technology and connectivity, we have to talk about challenges and concerns. Cybersecurity is a big one. As cars become more like computers on wheels, they also become potential targets for hackers. Manufacturers are investing heavily in securing their vehicle systems to prevent unauthorized access. Data privacy is another important topic. Smart cars collect a vast amount of data about where you go, how you drive, and even what you do inside the car. The question of who owns that data and how it's used is a major debate that society needs to address. And then there's the human element. How will we adapt to sharing the road with autonomous vehicles? How will we ensure these systems are reliable and make ethical decisions in unavoidable accident scenarios? These are complex questions that engineers, lawmakers, and all of us will need to work through together. But despite the challenges, the benefits are undeniable. Smart vehicles promise a future with fewer accidents, less traffic, reduced emissions, and more free time for us during our commutes. They can provide newfound mobility for the elderly and people with disabilities. So, the next time you see a car with a bunch of sensors on its roof, or you experience a feature like lane keeping assist, you'll know it's all part of this incredible technological revolution. We're living in a truly exciting time for the automotive industry. Watching the car evolves from a simple machine into a smart, connected partner for our journeys. The road ahead is full of innovation, and I can't wait to see where it takes us. Thanks for watching. If you found this video helpful and want to learn more about the future of technology, don't forget to like, subscribe, and hit that notification bell. See you in the next one.